All right. Welcome, physics guys. I'm going to go through a problem that we went through, a type of problem we went through in class. We're going to figure out how far away something is going to land when we're given a horizontal velocity and something dropped. It's going to do a little bit of parabolic motion here. And this bird wants to drop something on this man walking down below. Okay, so it says, a bird traveling horizontally at 50 meters a second wants to hit a man 100 meters below, so it's up a height of 100 meters, with a dropping. How far in distance before flying directly over the man should the bird release that dropping? Okay, and so we need to understand that Newton said when we figure distances, horizontal or vertical distances in physics, we have to figure these things separately because the horizontal and vertical velocities change, right? Horizontal doesn't change at all. Once that bird releases that dropping, the horizontal speed or velocity doesn't change at all, right? Because there's nothing pushing it or pulling it horizontally speaking. But there's gravity, of course, and that's what's pulling the object downward. So it gains velocity as it descends, right, over time. So what do we need to find out? We need to find out how long that dropping is going to be in the air, how long it's going to take to get from the bird 100 meters up in the air to the man down there on the ground. So what do we use? We use our good old friend 1/2 AT squared. In this case, I'm going to call it G because we know that the acceleration in this problem is the acceleration due to gravity. And since it's only going in one direction, we're not going up and then down, we're going to leave gravity. For us, it's just going to stay at positive 9.8 meters a second squared. Okay? We were already given the height, our distance in the y direction, right, of 100 meters. So we're going to take this formula right here, and we're just going to go ahead and write it out. So t, the time in the air, is going to be equal to the square root of 2 times 100 meters, because it's 100 meters above the human, right, divided by 9.8 meters a second squared, right? There we go. I'm going to rewrite it again right here, if I can fit it in. 200 meters over 9.8 meters a second squared. Sorry about the bell. That means school's over for the day, and I'm still recording the video. Here we go. Now, if I do this math in my calculator, I end up with 4.5 seconds, right? Because meters cancel out with meters and take the square root of second squared and you get seconds. So it takes 4.5 seconds to go from way up here all the way down here. Seems about right. And then I want to know how far away. Well, how far away do I have to be? Well, I already know what my horizontal velocity is. And now I know time. If I just multiply those two things together, I know how far away this object is going to land. So this bird can estimate how far it is that they need to release this. My horizontal velocity, of course, was given in the problem of 50 meters a second. So if I just solve, I have 50 meters a second multiplied by those. And what I'll end up with is 225 meters, right? So this bird needs to be 225 meters away from the guy, horizontally speaking, to land that dropping on that human, right? Now, if we wanted to know the actual distance from here to here, we could use the Pythagorean theorem. And we could say, okay, well, exactly how far does this need to be? Well, we could do 100 squared plus 225 squared. Take the square root, and that will give us our distance, right? That'll give us that distance. And if I take my calculator out and I put it in, and I say, okay, pardon me, the square root of 100 squared plus 225 squared, and I do the math, I am actually, or that bird is actually about 246, it's about 246.2 meters away, right? So hopefully this bird can really judge distances like that. I doubt it. It's just a silly physics problem up from a piece of paper, but that's how you figure it. Remember, this is a horizontal velocity. We can figure what the vertical velocity is, but we don't need to. We just need to know how long it's going to take to get from the bird to the ground. And that's what that 4.5 seconds was. All right, so please, there it is. I'm going to show you one problem a little later on, something fired at an angle, and we'll go through a big, long video of everything I need to know. All right, so thank you for your time. Enjoy this one.